The laws of electricity and magnetism are just some of the fundamental laws of nature. As I have said, all of these technologies that you have in mind are just consequences and applications of the fundamental laws of nature. However, it is important to consider that the laws of electricity and magnetism are included in these fundamental laws of nature. And now you may ask, what are the laws of electricity and magnetism which gave us practically all of the modern technologies that we have today? That is the question. What are these laws of nature that I am telling you na naging dahilan kung bakit tayo nagkaroon ng mga modern technology na meron tayo at ginagamit natin today? These laws are governed by a set of equations called Maxwell's equations. That's why tonight, our goal is to demystify these seemingly complicated equations. So on your screen right now, you can see the Maxwell's equations on the right side of the screen. As you can see here, these are the four Maxwell's equations that I'm referring to. Now, tonight, our goal is to understand the meaning and the significance of these equations rather than to delve and discuss the highly technical maths involved. So, guys, don't worry, hindi tayo magso-solve tonight, no? Hindi natin papaiyakin yung mga brain cells nyo because our goal is to demystify Maxwell's equations, meaning we will try to discover what the maths is trying to tell us. We will not do the math, but I will let you know and understand what these maths are trying to tell us. No, we will focus more on the meaning. No, what these equations mean. What do they imply? Okay? So, before the end of the lecture or this webinar, you should be able to understand the importance of these four Maxwell's equations. Now, since yan ay Maxwell's equations, this was named after, named after James Clerk Maxwell. No? And what are these Maxwell's equations? These are a set of four partial differential equations. As you have seen in the previous slides, these are not just simple equations. These are a set of partial differential equations. High-level equations yan, ano? Which describe all electromagnetic phenomena. These four equations are the mathematical basis of all electromagnetic phenomena. Kahit na anong bagay na maisip mo na may kinalaman sa electricity and magnetism, kayang i-explain ng apat na ito because they serve as the foundation of classical electromagnetism. Not only classical electromagnetism, that also includes classical optics, which is the study of light. All the electric circuits and magnetic circuits. So these four equations are powerful. Now, let me bring this back, the four equations that I have shown in the previous slide. No? These are the four equations that I am referring to. Huwag kayo masyadong ma-distract. Kung feeling nyo hindi nyo naiintindihan ang mga equations na yan, it's okay. Because tonight, our goal is to understand the meaning of these equations. But at the moment, I would like you to know that these four equations are the pillars of electromagnetism. Anything that has something to do with electricity, magnetism, or a combination of them can be explained mathematically by these four equations. That is how powerful these equations are. So, what specific systems have rooted, no, from these Maxwell's equations? Can we give some specific electrical systems na pwede nating ma-explain yung paggana because of Maxwell's equations? Yes. For electrical systems, we use Maxwell's equations to explain the operation of electric generators. No? Yun yung una, ano? Yung generator. Bakit? Kasi ganito yan eh. Yung generator ang ginagamit natin para magkaroon tayo ng kuryente. Ano? So even in a power plant, there is a generator. Generator is one of the most important elements in a power plant because it's the one that converts mechanical energy into electrical energy. So the operation of the generator can be explained by one of these four equations. No? So the operation and the design of motors, we use Maxwell's equations to describe transformers and all the electrical appliances that you have, including your cell phones and your laptops. Ganyan ka-powerful ang Maxwell's equations. Now, not only electrical systems, we use Maxwell's equations to describe the nature of optical phenomena, which when we understood, we used the concepts in order to develop various optical technologies. For example, nung naintindihan na natin kung paano gumana ang optics, we were able to develop imaging devices like binoculars, telescopes, projectors, and of course your camera, no? Your camera is an optical device. It works using the principles of optics, and the laws that govern optics are essentially Maxwell's equations. Now, radio technologies and wireless communications, we use radio frequencies, microwave frequencies in order to communicate wirelessly. And what are radio waves and microwaves? Basically, they are electromagnetic waves. And basically, electromagnetic waves have rooted from Maxwell's equations. Okay, actually, Maxwell predicted that there were electromagnetic waves simply by looking at his math. Pero inyo yun, na-predict ni Maxwell na may mga electromagnetic wave gamit lang yung mga equations niya. And then, later on, someone confirmed that his predictions were true. Later, I'll discuss that. So, the point of this slide is for you to realize the impact, the huge impact of these Maxwell's equations in our modern life. Yung mga Maxwell's equations na yan, ang fundamental mathematical foundations ng practically all modern technologies and devices na meron tayo. Okay? Of course, hindi lahat. Kaya nga sabi ko, practically all, but not all. Kasi may quantum pa eh. No? So dito, classical lang yung i-discuss natin, hindi natin isasama yung quantum theory. Classical pa lang ito. Okay? Now, let's before we delve into understanding Maxwell's equations, let us discuss first who James Clerk Maxwell is. Okay? James Clerk Maxwell is actually a 19th century Scottish physicist and mathematician. He's considered to be one of the most prolific scientists or mathematician and physicist of all time. No? Sabi nga ni Einstein, the works of James Clerk Maxwell is the second most important fruits of science after the works of Isaac Newton. That is according to Albert Einstein. So this Scottish mathematical physicist who lived from 1831 to 1879 is the one who is best known for his theory of electromagnetic wave. And he unified electricity and magnetism. He's best known for his grand unification of electricity and magnetism. So he did it, of course, mathematically. No? Okay. Prior to his unification, electricity is electricity and magnetism is another thing, and they are not related in any way. No, but time came when Maxwell unified electricity and magnetism into a single phenomenon, which he called electromagnetism. And according to Einstein, kagaya nga na nabanggit ko kanina, this is the second major unification in science after what Isaac Newton did. The first grand unification in physics is when Sir Isaac Newton unified the laws of gravity, no? Which is consistent with his laws of mechanics. The laws of mechanics that we use here on Earth are consistent with the laws of universal gravitation, which is the same laws that govern the motion of the planets around the sun. So it was Sir Isaac Newton who made the first grand unification in physics. Because the goal of physics, no science, specifically in physics, is to unify nature. Because according to scientists, there should be a grand unification in nature. The first unification was done by Newton, and the second was done by Maxwell when he unified electricity and magnetism. According to Maxwell, electricity, magnetism, and light are actually different manifestations of the same phenomenon. No? They are like branches of the same tree. Electricity, magnetism, and light. No? They are just different manifestations of the same phenomenon. That's why we can consider that electricity, magnetism, and light are just one. Para bagang sa Catholic faith, meron tayong tatlong persona, no? Yung tatlong persona na ay parang iisa. So ganun din ito, no? Yung electricity, yung magnetism, at saka yung light, according to Maxwell, they are just one, no? They are branches coming out of the same tree. Okay? So he's well known for his development of the electromagnetic field theory. However, what paved Maxwell the way for his grand unification? Of course, before Maxwell unified electricity and magnetism, some personalities before him made significant contributions. Ano yung na-unify niya? Ay di natural, yung mga discoveries ng kanyang mga predecessors. At isa na dyan ay ang taong ito. No? Sino sa inyo ang nakaka-recognize sa taong ito? Can you name this person? Can you name this person on the screen? Sino ito? Yes, that's right. Very good. This is Hans Christian Ørsted. No? Hans Christian Ørsted, who is a Danish physicist who lived from 1777 to 1851. What is the significant contribution of Ørsted? He was the first person to ever report the connection between electricity and magnetism. Actually, it was a myth, no? Yung kumakalat na kwento na accidentally na-discover ni Ørsted na may connection ang electricity at magnetism. Kasi minsan, aksidente sa kanyang pagle-lecture, gumalaw yung compass needle. Nung ang compass ay mapalapit sa isang electrical wire na may dumadaloy na kuryente. No? Actually, it was a myth. The truth is, Ørsted was actually trying to investigate the phenomenon. No? Kaso nga lang hindi niya ma-explain mathematically, no? But he was the first person to ever report that electricity and magnetism are somewhat related, no? Bakit? Kasi makikita natin kapag ang compass ay inilapit sa isang electrical wire na may dumadaloy na kuryente, yung compass needle na alam nating magnetic ay nagde-deflect. O di ba? We know that compass is magnetic and the wire which carries current is electric. How can something electric affect something magnetic? Yun ang naisip niya. That's why he thought that electricity and magnetism must be related. No? Nagkakaroon ng effect yung electricity sa magnetism, which is proven when a compass needle has been deflected when placed close to a current-carrying conductor. But what was the dilemma of Ørsted? He doesn't really know how to express mathematically what he discovered until the news reached the other parts of Europe. No, specifically this person. No, can you name this person that I'm showing right now? Sino ito? Sino ang nakakakilala sa kulot na ito? This is not Faraday. This is not Faraday. Faraday was English, but this one is French. Pero hindi siya fries. French lang siya, pero hindi siya fries. Hindi rin siya kiss. French lang siya. Fourier. Fourier is French, but this is not Fourier. Someone said Ampere. No? Another one said Ampere. That's right. No? Ladies and gentlemen, this is Andre Marie Ampere, no? From the Kingdom of France during the 1700s.